In this video, we're going to talk about indices, the laws of indices. But first off, I would like us to understand the concept of indices. When we have numbers multiplying each other, say we have 3 times 3. To write it in a more compact form, we would say equals to 3 to the power of 2. Now, this 2 is referred to as index. The plural form of index is simply indices. Now, there are laws that guide how we represent this kind of numbers. To start off, for the first one, we have, say you have a number A with an index of M, multiplying that same number A with an index of N, the power becomes A to the power of N plus N. For an example, say I have 3 raised to power 3 times 3 raised to power 2. That would mean saying 3 raised to power 3 would be 3 3s, so it would be 3 times 3 times 3 times 2 3s. So I'd have 3 times 3. Counting all of them, I'd have 3 plus 1, 2, 3, 4, 5. So this is 3 to the power of 5. So the idea is just add the two powers of the same base number multiplying each other. You just add both of them. So for the second law of indices, if I have a number, say I have A to the power of M, and I have an N that's powering it outside, this would mean A, and then the powers are going to multiply. So I'd have M times N. The result would be A, M, N. An example of this would be, say you have 3 raised to power 2, and then you have a power of 2 outside the bracket. This would still mean 3 raised to power 2 times 3 raised to power 2. If we were to expand this, it would be simply saying 3 times 3, and then for the second 3 raised to power 2 times 3 times 3. So this is 3 raised to power 4. And then if we were to apply this law, it's simply just say 2 times 2 is 3 raised to power 4. So for my third law, I'd have, saying we have a base number, let's use B in this case, B raised to power M divided by B raised to power N. We could also represent this as saying B raised to power M minus N. An example would look like, say I'm saying 5 raised to power 4 divided by 5 raised to power 2. Expanding this thing, it would look like, say this 5 raised to power 4, or writing it in that form, divided by 5 raised to power 2. So this is 5 times 5 times 5 times 5 divided by 5 times 5. So I'll be cancelling 5, this one, and then this 5 with this one. So I'd ultimately have 5 times 5. To write it in a short form, or the index form, I'd have 5 squared. But if I were to apply this law, I'll just say 5 raised to power 4 minus 2, which is equal to 5. 4 minus 2 is 2. So it's basically the same thing. And then the fourth law is a to the power of 0. So if you have a base number that has a power of 0, the answer is equal to 1. And then the fifth law is saying if I have a number with the negative power of 1, this would be equivalent to saying 1 times 1 over a. Since the power is 1, I'm having a 1 here, and then 1 over a is because of the negative power here. So this becomes 1 over a. And then the fifth law is saying if I have the sixth law, is saying if I have a to the power of 1 over a number, say z, this would mean that the roots of z, I should take the roots of z for the number a. So when I have, say I have 3 raised to the power of 1 over 2, I should just simply take the square root of 3. Or say I have 4 to the power of 1 over 2, I should simply just take the square root of 4. Or say I have 5, 1 over 3, I should simply just take the cube root of 5. Okay, so for the seventh law, you have a number a to the power of, let's say, 5 b over c. This would simply mean, like the way we did it here, you take the c roots of a, but then you'd also power the whole thing by b. So it's just like a modification of this one. In this case, we powered it by 1, so it didn't have any effect. But in this case, we're powering it by b. So that's the laws of indices in a simplified format. Thank you for watching this video.